All right, let's break it down even more. We're going to explore how you can tell if a number can be divided by 3 or 9 just by looking at its digits. This is a neat trick, and once you get it, it's really easy to use. What does divisible by mean? Before we dive in, let's make sure we understand what it means for a number to be divisible by another number. When we say a number is divisible by 3, it means that if you divide it by 3, there won't be any leftovers or remainder. The same goes for divisible by 9. If a number is divisible by 9, dividing it by 9 leaves no remainder. Check divisibility by 3. The rule, a number is divisible by 3 if the sum of its digits is also divisible by 3. Steps to check if a number is divisible by 3. 1. Add up all the digits of the number. 2. Check if the result, the sum, can be divided by 3 with no leftovers. 3. If it can, then the original number is also divisible by 3. Example 1. Checking if 1, 2, 3 is divisible by 3, 1. Take the number 1, 2, 3, 2. Add the digits together. 1 plus 2 plus 3 equals 6. 3. Check if 6 is divisible by 3. Yes, it is. 6 where 3 equals 2 with no leftovers. 4. Since 6 is divisible by 3, SNOR 1, 2, 3 is also divisible by 3, 3. Example 2. Checking if 85 is divisible by 3. 1. Take the number SAR 85. 2. Add the digits. 8 plus 5 equals 13. 3. Check if 13 is divisible by 3. No, it's not. 13, 3 equals 4 with 1 left over. 4. So 85 is not divisible by 3. Divisibility by 9. The rule, a number is divisible by 9 if the sum of its digits is also divisible by 9. Steps to check if a number is divisible by 9. 1. Add up all the digits of the number. 2. Check if the result, the sum, can be divided by 9 with no leftovers. 3. If it can, then the original number is also divisible by 9. Example 1. Checking if 189 is divisible by 9, 1. Take the number of 189. 2. Add the digits together. 1 plus 8 plus 9 equals 18. Check if 18 is divisible by 9. Yes, it is. 18, 9 equals 2 with no leftovers. 4. Since 18 is divisible by 9, 189 is also divisible by 9. Example 2. Checking if 225 is divisible by 9, 1. Take the number 225, 5. 2. Add the digits together. 2 plus 2 plus 5, 3. Check if 9 is divisible by 9. Yes, it is. 9 over 9 equals 1 with no leftovers. 4. Since 9 is divisible by 9, 225 is also divisible by 9. Why these rules work? These rules work because of the way our number system, called base 10, is structured. When we write a number like 1, 2, 3, it's really a combination of hundreds, tens, and ones. The numbers 3 and 9 have a unique property in base 10. If the sum of all the digits in a number can be divided by 3 or 9, then the whole number can be divided by 3 or 9 too. Practice time! Let's try a couple more to make sure it's clear. 1 is 72 divisible by 3. Add the digits. 7 plus 2, 9. Is 9 divisible by 3? Yes. So 72 is divisible by 3. 2 is 527 divisible by 9. 9. Add the digits. 5 plus 2 plus 7, 14. Is 14 divisible by 9? No. So 527 is not divisible by 9. Quick summary. For 3, add the digits. If the sum is divisible by 3, the whole number is 2. For 9, add the digits. If the sum is divisible by 9, the whole number is 2. With this trick, you can quickly check if a number can be divided by 3 or 9 without any remainders. Try it out with some random numbers and see the magic in action. All right, let's make it even simpler and go over every little detail. We'll go slow, step by step. What are we trying to do? We want to check if a number can be divided by 11 without any leftovers, which means it's divisible by 11. How do we do it? For divisibility by 11, we use a special rule that makes it easy to check any number. Here's the rule, explained as simply as possible. Divisibility rule for 11, 1. Start with all the digits of your number. 2. Add and subtract the digits, going one by one from left to right. First, add the first digit. Then subtract the second digit, then add the third digit, subtract the fourth digit, and keep going like this. Add, subtract, add, subtract. 3. When you finish, you'll have a final result. 4. Check the final result. If the result is 0 or any number that divides by 11, then the original number is divisible by 11. If it's not, then the number isn't divisible by 11. Let's break it down with examples. Example 1. Is 39160 divisible by 11? 1. Write down the number plus 3 through 5916. 2. Follow the steps to add and subtract. First digit 3, second digit 9, subtract 9. Third digit 1, fourth digit plus 6, subtract. Now it's 6, 3. Now let's do the math. -3 minus 9 plus 1 minus 6 equals 11. 4. Check if minus 11 is divisible by 11. Yes, minus 11 divides by 11 with no leftovers. So 39116 is divisible by 11 times. This example 2, is 524 divisible by 11? 1. Write down the number 524. 2. Add and subtract each digit. First digit 5, add 5, second digit 2, subtract 2 minus third digit 4, add 4, 3. Now let's do the math. 5 minus 2 plus 4 equals 7. 4. Check if 7 is divisible by 11. No, 7 doesn't divide by 11 evenly, so 521 is not divisible by 11. One more example for practice. Is 56798 divisible by 11? 1. Write down the number 56798. 2. Add and subtract each digit. First digit 5, add 5. Second digit 6, subtract 6. Third digit 7, add 7. Fourth digit subtract 9. Fifth digit 8, add 3. Now let's do the math. -5, 6 plus 7 minus 9 plus 8 equals 5. 4. Check if 5 is divisible by 11. No, 5 doesn't divide by 11. So 56798 is not divisible by 11. Quick recap. 1. Alternate adding and subtracting each digit, starting from the left. 2. Look at the final result. If it's 0 or a number that divides by 11, the original number is divisible by 11. If not, it's not divisible by 11. Why does this rule work? This rule works because of the structure of our number system. By alternating addition and subtraction of digits, we're actually checking if the number fits into groups that 11 divides evenly. But you don't need to worry too much about the why for now. Just remember the rule and the steps. Let's break down the rule for divisibility by 11 in an even simpler and slower way. We'll go through each step carefully so it's easy to follow and understand. Step 1. What does divisible by 11 mean? When we say a number is divisible by 11, it means that if we divide the number by 11, we get a whole number with no remainder. For example, 33 is divisible by 11 because last 33 to have all the no remainder. Or 44 is also divisible by 11 because 44 or 11 equals 4 remainder. But 45 is not divisible by 11 because 45 or 11 equals 4 with a remainder of 1. Step 2. Why do we need a trick? Sometimes we don't want to actually divide a number by 11 to check if it's divisible. We might not have a calculator, or maybe we want a fast way to know the answer. Step 3. The trick for divisibility by 11. Here's the rule to check if a number is divisible by 11 without dividing. 1. Separate the digits into 2 groups. Odd position digits. These are the first, third, fifth, etc. digits of the number. Even position digits. These are the second, fourth, sixth, etc. digits. 2. Add up the odd position digits. 3. Add up the even position digits. 4. Subtract the 2 sums. 5. Check the result. If the result is 0 or a multiple of 11, like 11, 22, etc., the original number is divisible by 11. If it's not a multiple, the number is not divisible by 11. Let's work through a step-by-step example. Let's say we want to check if 91808 is divisible by 11. 1. Write down the number 918082. 2. Identify the digits by position. Odd position digits 9, 8, 8, first, third and fifth positions. Even position digits 1, 0, second, fourth and sixth positions. 3. Add up the odd position digits. 9 plus 8 equals 25. 4. Add up the even position digits. 1 plus 0 plus 2 equals 3. 5. Subtract the 2 sums and that's 25 minus 3, 22. 6. Check if 22 is a multiple of 11. Yes. 22 but 11 equals 2, a whole number with no remainder. Since 22 is a multiple of 11, this means 918282 is divisible by 11 off. Another example to make it clear. Now let's try with 55524 to see if it's divisible by 11. 1. Write down the number 524. 2. Identify the odd and even position digits. Odd position digits 5, 4, first and third positions. Even position digit 2, second position. 3. Add up the odd position digits. Minus 5 plus 4 equals 9. 4. Add up the even position digit. 2, 5. Subtract the two sums. 9 minus 2 equals 7. 6. Check if 7 is a multiple of 11. No, it's not a multiple of 11. Since 7 isn't a multiple of 11, 524 is not divisible by 11. Let's try another example with more digits. Let's use 76864 and see if it's divisible by 11. 1. Write down the number 76864. 2. Identify the odd and even position digits. Odd position digits 781, first, third and fifth positions. Even position digits 6, 6, 4, second, fourth and sixth positions. 3. Add up the odd position digits. 7 plus 8 plus 1 is 16. 4. Add up the even position digits. 6 plus 6 plus 4 equals 16, 5. Subtract the two sums. 16, 16 equals 0. 6. Check if 0 is a multiple of 11. Yes, 0 is divisible by every number, including 11. So 7686144 is divisible by 11. Why this trick works? Very simply. This trick works because of the way we use place values in our number system. The alternating addition and subtraction mimic a pattern that aligns with multiples of 11. But for now, just remember the steps, practice with examples, and you'll be able to check divisibility by 11 easily. Quick summary of the rule. To check if a number is divisible by 11. 1. Add the odd position digits. 2. Add the even position digits. 3. Subtract the two sums. 4. If the result is 0 or divisible by 11, then the original number is divisible by 11. This is a quick trick to check divisibility by 11 without needing a calculator. Alright, let's go even slower and deeper into each rule, breaking it down step by step and explaining every little detail. 1. Divisibility by 2 rule. A number is divisible by 2 if its last digit is even. What are even numbers? Even numbers end in 0, 2, 4, 6, or 8. If a number ends in one of these digits, it can be divided by 2 without any leftovers. Why does this work? Any number ending in an even number can be split evenly into two groups. Examples. 1. 36 ends in 6 even, so 36 is divisible by 2. 2. 15 ends in 5 odd, so 15 is not divisible by 2. Back to divisibility by 5 rule. A number is divisible by 5 if its last digit is 0 or 5. Why does this work? Numbers that end in 0 or 5 create equal groups of 5 when divided. Examples. 1. 40 ends in 0, so 40 is divisible by 5. 2. 23 ends in 3, so 23 is not divisible by 5. Extra trick. If the last two digits form a number divisible by 25, then the whole number is also divisible by 25. 100, 225, 450, 75, all end in numbers like 00, 25, 50, 75, which divide by 25. 3. Divisibility by 4 rule. A number is divisible by 4 if the last two digits form a number that's divisible by 4. Why does this work? Dividing by 4 breaks a number into groups of 4, so only certain last two digits will work, like 00, 04, 08, 12, etc. Examples. 1. 312. Last two digits are 12. Since 12 is divisible by 4, the whole number 312 is also divisible by 4. 2. 275. Last two digits are 75. Since 75 is not divisible by 4, the whole number 275 is not divisible by 4. 4. Divisibility by 8 rule. A number is divisible by 8 if the last three digits form a number that is divisible by 8. Why does this work? Dividing by 8 breaks a number into groups of 8, so only certain last three digit combinations would work, like 48, 16, etc. Examples. 1. 1048. Last three digits are 048 or just 48. Since 48 is divisible by 8, the whole number with having 48 is divisible by 8. 2. 2 and 3 665. Last three digits are 365. Since 365 is not divisible by 8, the whole number 2365 is not divisible by 8. 5. Divisibility by 3 rule. A number is divisible by 3 if the sum of its digits is divisible by 3. Why does this work? Adding the digits of a number together reveals if it can be split into equal groups of 3. Examples. 1, 1, 2, 3. Sum of digits equal 1 plus 2 plus 3 equals 6. Since 6 is divisible by 3, 123 is divisible by 3. 2, 124. Sum of digits 1 plus 4. Since 7 is not divisible by 3, 124 is not divisible by 3. 6. Divisibility by 9 rule, similar to 3. A number is divisible by 9 if the sum of its digits is divisible by 9. Why does this work? Similar to 3, but we're checking for groups of 9 instead of 3. Examples. 1. 7 and 29. Sum of digits equals 7 plus 2 plus 9 equals 18. Since 18 is divisible by 9, 7 and 29 is divisible by 9. 2. 5 26. Sum of digits equals 5 plus 2 plus 6 equals 13. Since 13 is not divisible by 9, 526 is not divisible by 9. 7. Divisibility by 10 rule. A number is divisible by 10 if its last digit is 0. Why does this work? Numbers ending in 0 can be divided evenly by 10, like 10, 20, 30. It's examples. 1. 50. Last digit is 0, so 50 is divisible by 10. 2. 43. Last digit is 3, so 43 is not divisible by 10. 8. Divisibility by 11 rule. A number is divisible by 11 if the difference between the sum of its digits in odd positions and the sum of its digits in even positions is either 0 or divisible by 11. Why does this work? This pattern shows whether a number can split into equal groups of 11 based on its digit arrangement. Examples. 121. Odd positions. 1 plus 1 equals 2. Even position, 2. Difference 2 minus 2 equals 0. 0 is divisible by 11, so 121 is divisible by 11. 2. 1, 2, 34. Odd positions. 1 plus 3 equals 4. Even positions. 2 plus 4 equals 6. Difference equals 6 minus 4 equals 2, not divisible by 11, so 2, 34 is not divisible by 11. 9. Divisibility by 7 rule. This one's a bit trickier. 1. Remove the last digit. 2. Double that digit. 3. Subtract it from the rest of the number. 4. Check if the result is divisible by 7. Repeat if it's still large. Examples. 1. 532. Remove the 2. Double it. 2 times 4 and subtract it from 53. 53 minus 4 equals 49. Minus 49 is divisible by 7, so 532 is divisible by 7. 2. 2 and 3. Remove the 3, double it, 3, 2, 6, and subtract it from 20. 20 minus 6 equals 14. Minus 14 is divisible by 7, so 203 is divisible by 7. Summary. These divisibility rules let you figure out if a number divides evenly into another without actually dividing. 2, if the last digit is even. 5, if the last digit is 0 or 5. 4, if the last 2 digits form a number divisible by 4. 8. If the last 3 digits form a number divisible by 8. 3. If the sum of the digits is divisible by 3. 9. If the sum of the digits is divisible by 9. 10. If the last digit is 0. 11. By subtracting and adding positions. 7. With a special trick of doubling and subtracting. Use these rules to quickly figure out divisibility and you'll become faster at mental math. Let me know if you need more help with any specific part. All right, let's break this down super slowly, step by step, in the simplest language possible. We'll go through each part like a game and use easy examples to understand how this divisibility rule 4-7 works. Divisibility by 7, the rule in simple words. This rule tells us if a number can be divided by 7 with no leftovers. Here's what to do. 1. Look at the number you have. 2. Take off the last digit, the number in the ones place. 3. Double, multiply by 2, that last digit you took off. 4. Subtract that doubled number from what's left of your original number. If you keep repeating this and get a small number that you know can divide by 7, then your original number is divisible by 7 too. Why does this work? Imagine numbers are like groups. This rule helps us find out if we can make groups of 7 with no extras left over. We play a little game with the number to check. Let's try an easy example. First, let's check if the number 42 is divisible by 7. 1. Starting with 42, last digit is 2. 2. Take off the last digit 2. So now we have just 4 left from 40. 3. Double the last digit, 2, 2, 4. 4. Subtract this doubled number 4 from what's left 4. 4 minus 4 equals 0. Since we got 0, which can be divided by 7, 0 divided by anything is still 0. 42 is divisible by 7. A bigger example, checking if 876 is divisible by 7. Let's go through this in little steps. 1. Starting with 876. Last digit is 6. 2. Take off the last digit. Now we have 87 left. 3. Double the last digit, 6. 6 times 2, 12. 4. Subtract 12 from what's left, 87. 87 minus 12 equals 75. Since 75 is still kind of big, let's repeat the step. 5 starting with 75, last digit is 5. 6, take off the last digit. Now we have 7 left. 7, double the last digit, 5. 5 times 2 equals 10. 8, subtract 10 from what's left, 7. 7 minus 10 equals minus 3. Since minus 3 doesn't really help us here, and 75 isn't divisible by... Alright, let's go through the divisibility rule for 13 in the simplest, clearest way possible. Divisibility rule for 13. This rule tells us how to check if a big number can be divided by 13 without actually dividing it. Here's the rule step by step. 1. Take off the last digit of the number, like peeling off the last number at the end. 2. Multiply that last digit by 9. 3. Subtract this result from what's left of the number. 4. Repeat this process until you get a small number you can check to see if it's divisible by 13. If the final result is divisible by 13, then the whole original number is also divisible by 13. Why does this rule work? This rule works because multiplying the last digit by 9 and subtracting it is a shortcut. It's a special way to break down the number while keeping track of 13. We chose 9 as the multiplier because 9 helps to form bundles of 13. We can say that it's like grouping parts of the number into pieces that add up to multiples of 13. Let's try an example to make it clear. Example. Checking if 5,616 is divisible by 13. Let's go through each step with this number. 1. Start with 5,616. Last digit is 6. Multiply 6 by 9, 6, 9 equals 54. Subtract 54 from the rest of the number. 5 to 5 and 61, 9, 54 equals 507. 2. Continue with 5 or 7. Last digit is 7. Multiply 7 by 9. 7 times 9 equals 63. Subtract 63 from the rest of the number. 50. 50 now 63 equals 90, 13, 2. 3. Check 9 as 13 is divisible by 13. 5,616 is also divisible by 13. More practice and tips. This method may seem unusual, but it's a clever way to avoid big division. If you want to check more numbers, 1. Pick any number. 2. Follow the steps. Take off the last digit, multiply by 9, subtract. 3. Keep going until you get a small number you can recognize as divisible by 13. For example, try 7,150. 1. Last digit is 0, so no change. 2. This means it's up to you to keep going, or you've learned that if the number after Alright, let's explore the divisibility rule for 17s and break it down in the simplest way. Divisibility rule for 17. This rule helps us check if a number is divisible by 17 without actually dividing by it. Here's how. 1. Remove the last digit of the number, like taking off the last number on the right. 2. Multiply that removed digit by 5. 3. Subtract this result from the remaining part of the number. 4, repeat this process until you get a small number that you can easily check for divisibility by 17. If the final result is divisible by 17, then the entire original number is divisible by 17. Why does this work? Each time we remove a digit and multiply it by 5, we're essentially making bundles of 17 and subtracting them out. This keeps us connected to the number 17, and eventually we'll get a small enough number that shows if 17 fits into it evenly. Example, checking if 1224 is divisible by 17. Let's go through each step with this number. 1. Start with 1224. Last digit is 4. Multiply 4 by 5. 4 times 5, 20. Subtract 20 from the rest of the number, 122. 122 to minus 20 equals 102. 2. Continue with 102. Last digit is 2. Multiply 2 by 5. 2 times 5 equals 10. Subtract 10 from the rest of the number, 10. 10 plus 10 equals 0. 3. Check the result. 0 is divisible by 17, so 1224 is also divisible by 17. Making it easy to remember. If you want to use this rule, remember, take off the last digit, multiply 5, subtract and repeat until you reach a small number. Once you reach a manageable number, check if it's divisible by 17. Practice tip. Try using this rule with any number you want to test for divisibility by 17. This helps you get familiar with the steps and makes you faster at checking larger numbers without dividing. Let's dive even deeper and make everything as clear as possible. We'll go step by step as if starting from scratch and keep it super simple. 1. What is a composite number? A composite number is a whole number that can be divided by other whole numbers besides just one in itself. This means it has multiple factors, numbers that divide it evenly. Examples of composite numbers. 4, it can be divided by 1, 2, and 4. 6, it can be divided by 1, 2, 3, and 6. And 8, it can be divided by 1, 2, 4, and 8. Key point. A composite number is not a prime number. Prime numbers have only 2 factors, 1 and the number itself, like 2, 3, 5, 7. 2, what are factors? Factors are numbers that multiply together to make another number. The factors of 6 are 1, 2, 3, and 6. Minus 2 and 3 are factors of 6 because 2 times 3 equals 6. When we say a number is such or divisible by its factors, it means that dividing by that factor leaves no remainder. Example, 6 divided by 2 is 3 with no remainder, so 6 is divisible by 2. Tab 3. What does relatively prime mean? When 2 numbers have no common factors besides 1, they are called relatively prime to each other. This means they don't share any other factors. Example, the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. 2 and 3 are relatively prime because they don't share any factor other than 1. Number 4, divisibility by composite numbers, the main rule. If we want to check if a number is divisible by a composite number, we can break down the composite number into its relatively prime factors. If the number is divisible by each of these factors, then it is also divisible by the composite number. Example with the number 6. 6 is a composite number. It has relatively prime factors, 2 and 3. If a number can be divided by both 2 and 3, then it is also divisible by 6. 5 examples of using this rule. Let's go through some examples to understand how to use this rule. Example 1, checking if 18 is divisible by 6 timer. 6 has factors of 2 and 3s. These are relatively prime. To check if 18 is divisible by 6, 1. Check if 18 is divisible by 2, since 6 has a factor of 2. 18 is an even number, ends in 0, 2, 4, 6, or 8, so it's divisible by 2. 2. Check if 18 is divisible by 3, since 6 has as a factor of 3. Add the digits of 18. 1 plus 8 equals 9. 9 is divisible by 3, so 18 is also divisible by 3. 3. Since 18 is divisible by both 2 and 3, 18 is divisible by 6. Example 2, checking if 36 is divisible by 12. 12 is a composite number with relatively prime factors 3 and 4. To check if 36 is divisible by 12, 1. Check if 36 is divisible by 3. Add the digits. 3 plus 6 was 9, and 9 is divisible by 3. 2. Check if 36 is divisible by 4. Look at the last two digits, 36. Since 36 is divisible by 4, 36 meets this condition. 3. Since 36 is divisible by both 3 and 4, 36 is divisible by 12. How? 6. Creating a chart of composite numbers and their relatively prime factors. To make it easier, let's list composite numbers up to 48 and show their relatively prime factors. Composite number, relatively prime factors. 6, 2, 3, 8, 2, 9, 3, 2, 2, 5, 12, 3, 4, 14, 2, 7, 15, 15, 5, 2, 2, 3, 20, 2, 2, 5, 24, 3, 80, 2, 3, 5, 36, 3, 4, 45, 3, 3, 7, 45, 48, 16. Using this chart, you can easily test if a number is divisible by any of these composite numbers. Just check for divisibility by each of its factors. Why this rule works. Composite numbers are made up of simpler parts, factors. If a number is divisible by these simpler parts, it's also divisible by the bigger composite number they make up. This makes it easy to test divisibility without doing long division. 8. Practice with this rule. Try using the rule on different numbers to see if they are divisible by 6, 12 or other composite numbers in the chart. Example practice problem. Is 120 divisible by 30? Check the factors of 30, 2, 3 and 5. 120 is divisible by 2, it's even. By 3, 1 plus 2 plus 0, 3, and by 5 ends in 0. Since it's divisible by all three, 120 is divisible by 30. Summary. A composite number has multiple factors. To see if a number is divisible by a composite number, break down the composite number into its relatively prime factors. Test if the number is divisible by each of those factors. If it is, then it's divisible by the composite number. This method saves time and helps with understanding numbers better. Keep practicing, and it will soon become second nature. Alright, let's break down this trick for squaring numbers ending in 5. I'll explain it as simply as possible so you'll understand each step, and then we'll look at why it works. Step-by-step guide, squaring numbers ending in 5. 1. What we're doing. We want to square a number that ends in 5. Squaring means multiplying a number by itself. 2. The trick. If a number ends in 5, we can use a special shortcut to find its square quickly. This works for any number that has a 5 as its last digit, like 25, 35, 85, and so on. How the trick works. Let's go through the steps using an example. Example, 85 squared, 85 square 1. Step 1, remove the last digit, the 5, take the number 85, remove the last digit 5, so you're left with 8, 2. Step 2, multiply the remaining number by the next number. Now, take the number you have left, 8, multiply it by the next number, which is 8 plus equals 9. 8 times 9 equals 72 through 3. Step 3, put 25 at the end. Now, just put 25 at the end of your result from step 2. So we take 72 and add 25 at the end, making it 725. For the answer, 85 squared, 85 times 85 is 7225. 2. Another example to practice, 35 squared, 35 squared 2. Let's try this again with 35 to make sure we've got it. 1. Step 1, remove the last digit 5. You're left with 3. 2. Step 2, multiply 3 by the next number, 4. 3 times 4 equals 12. Step 3, add Psalm 25 at the end. So the answer is 1225. Therefore, 35 squared is 1225. Why does this trick work? To understand why this trick works, let's look at what's happening with the math. 1. The original number, any number that ends in 5, can be written as 10n plus 5, where n is the part of the number before the 5. For example, 85 is 10 times 8 plus 5, and 35 is 10 times 3 plus 5. 2. Squaring the number. When we square 10n plus 5 tar, we're really doing this math. 10n plus 5 times 10n plus 5 equals 100n's 100n plus 25. Means this simplifies to plus 100 times n plus 1 plus 25, 25. 3. Meaning of each part. The part 100 times n plus 1 tile is the main part of the answer. The 25 at the end is always there because we're squaring a number that ends in 5. This is why we put 25 at the end after finding n to n plus 1 tar. Practice makes perfect. Try out a few numbers yourself to get the hang of it. Here are some examples. 1, 65 squared. Remove 5, left with 6. 6 times 7 equals 42. Add 25, answer is 1425. 2, 95 squared. Remove 5, left with 9. 9 times 10 equals 90. Add 25, answer is 995. 3, 45 squared. Remove 5, left with 4. 4 times equals 20. Add 25, answer is 2025. Summary of the steps. Remove the last 5 in the number. Multiply the remaining part by the next number up. Add 25 at the end. This gives you the square of the original number. Why this is useful? This shortcut is quick and doesn't need a calculator or long multiplication. By practicing this trick, you'll get faster at squaring numbers that end in 5, which can be helpful in math tests, mental math, or any time you need to calculate squares in your head. With this method, you'll be squaring numbers ending in 5 like a pro. All right, let's break it down even more step by step to make it super clear. This trick is all about squaring any number easily by breaking it into parts. We'll go over each part slowly and use examples so it feels simple and easy to follow. The goal, we want to find a quick way to square any number, to multiply a number by itself without doing big, hard multiplications. The idea is to split the number into 2 parts. One part that's easy to work with, another part that's also simple. We can then square each part separately and combine the results. The formula we use in simple words, when we split a number into 2 parts, let's say A and B, the square of the whole number can be found by 1, squaring A, 2, squaring B, 3, multiplying A and B, then doubling that result. 4, adding all these parts together. In math, this is written as AB squared 2 equals A2 plus 2 times B3, 2. But let's skip the symbols and focus on how to do it with real numbers. Example 1, squaring 73. Let's go through this example in detail. Step 1, break down 73 into 2 parts. We can think of 773 as 70 plus 3. So A equals 70 and B equals 3, Step 2, square each part separately. Square 70a, 70 times 70 equals 4900 because 7 times 7 equals 49 and then we add 2 zeros. Square 3b, 3 times 3 equals 9. Step 3, multiply ab, then double it. Multiply 70 and 3. 70 and 3, 70 times 3 equals 10, double that result, 2n times 2 is 420. Step 4, add everything up. Now we add up all the pieces we got, 4,907 quid, from doubling 70 times 3 and 900 from 3, 2. So 4,900 plus 420 plus 9 equals 503.29. That means 73 squared is 503.29. Example 2, squaring 29. Let's try a smaller number like 29. Step 1, break down 29 into 2 parts. We can think of 29 as 30 minus 1 top. So A equals 30 and B equals minus 1. Step 2, square each part separately. Square 30A, 30 times 30 equals 900. Square minus 1, B minus 1 times 91 equals 1. 2 negatives make a positive. Step 3, multiply A and B, then double it. Multiply 30 and minus 1 equal minus 30. Double that result. 90 times 2 equals 60. Step 4, add everything up. Now we add up all the pieces we got. 932 minus 60 from doubling, then 30 times minus 1 from minus 1 squared 2. So 900 minus 60 plus 1 equals 841. That means 29 squared is 841. Why this works? This method works because when we square a number, really adding up parts of it like pieces of a puzzle, each part represents a piece of the multiplication, and we're just organizing them into easy chunks. By squaring each part and doubling the middle part, we can quickly reach the full answer without doing huge multiplications. Summary: to square any number, 1. Split it into 2 easy parts. Usually one part is close to a round number, like 10, 20, 30, etc. 2. Square each part on its own. 3. Multiply the 2 parts together, double it, and add it to the squares. 4. Add all the results to get the final answer. This way, you can square any number easily by using smaller, simpler calculations.